Hello. In class we went over structures, and we're up to structures that are growing into objects, protective objects. But before we do, one more time, I want to look at structures with you and build tools. Tools, yeah, small functions to work with these creatures or a particular problem. All right, our particular problem, we're going to look at a point. Again, let me get my laser going. So here it is, a point. Here's another point. We could have many points. And we designed this simple structure. 2 dimensions, we want to call X and Y. And we picked these names because that's what people call these things, X and Y. So why do something strange? So we have this new data type called point. It's a blueprint. Here's another idea. What if we wanted to create a rectangle? Rectangles are 2 points. We don't need all 4 points for a rectangle. They're implicit. That is, you give me P1, if I look up the x-axis and I look across y with P2, I'll get this one here, this point. The same with the bottom point, so I only need 2. Having the top right and the bottom left, we would call standard or canonical form. We need at least a top and a bottom one. So let's make a point. Here's the first version. You give me an x, give me a y. I'll have a temporary variable, temp, and it'll be a point. I'll set x, the x coming in to this x, and the y coming in to this y. So a copy is made going like this. So now this temp is really a point, and we're going to return, C++ will allow us to return a copy back this way. Great. But here's another version of it. Less wordy. Here's x will go in here, y will be plopped down in here, and notice we said it's a point, and we're initializing it just like an array. And we have to keep in mind what the structure really looks like. X will be the first variable, so I have to make sure it's the first here, and y is the second. So all these things line up nicely. C++ will create a point and return it to me. Yes, and we call this thing makePoint. We use a word to combine these 2 numbers together to create our object. This is a very good technique. Here's an example. We have a variable a, which is a point, and we ask makePoint to take 2 integers and create point A for me. And if I want to print it out, I have to do this whole thing right here to see y and to see x. Great. This would be a lot nicer. You give me a point. What we'll end up doing is teaching this operator, the insertion operator, when you give me an output stream like cout, it will take the point, take the y out here, take p, and it will print out, it'll send out a parenthesis, x, a comma, y, a close parenthesis, and return that to me. This is so we can have a chain of couts. We can do the same thing with a rectangle. You give, I should have used an R here instead of a P, but I used P because I did a cut and paste pretty much. So give me a point, excuse me, a rectangle. Again, I should have used R. Much better calling it R. So it will turn around and take out R of A, but what is R of A? We go back a few slides. Oh, here it is. When you have a rectangle, the first point is called A, and the second point is B. So we have a point A And we have a point B. I probably should have called it point 1 and point 2. So now I'm just saying print out a point. This is a point. This is a point. But one slide ago, we actually taught C++ how to work with points. So the bottom code will simply have the compiler come up here and use this code. And so I changed the symbol here to a brace, an open and close brace, because when you print this one out, it's going to have parentheses around two numbers with a comma, a digit, comma, and then a comma here, and like this. So rectangles will look like point 1 and point 2. Here's an example, a video screen, your monitor. This is sort of like in Windows. Make a point for the bottom left of the screen. Make a point for the top right-hand corner. All right, so what's our screen? Screen has the bottom point and it has the top right point. And I say your screen size is, and I'll print it out. Here's another fun one. Suppose I want the middle of the screen. I could say screen, go to your first point X. Screen, go to your second point X. Divide them by 2 to get the middle. So I call that mid-X. Same with Y. Point 1, go to Y. Point 2, go to Y. Just add them up and then divide that whole thing by 2. So I have my midpoints, mid-X and mid-Y. And I can make this a middle point. I say take X, take Y, make a point. Great. And initialize the variable middle. And what is middle? It's going to be the point X and Y, because that's what middle wants. And we can say your middle is at, and because we overloaded the insertion operator, this will print out something beautiful. Here's an example of some code all put together. Rectangle, a screen, point 1, point 2, show me your screen. Get the middle point of X, get the middle Y, and show me the middle point. Notice I broke this up into 2 steps, actually a 3rd step right there. And then I take a look at the result. Here's a more complete picture of main. Notice I just included the end and the top of main. And it shows us your screen size. Here's the point. Here's the second point. So it's telling me I have a screen from here to here. Next, it tells me where's my middle. My middle is over here somewhere. Great. What if I wanted the distance between 2 points? I'm creating a video game, so I want this distance. How do we do that? We play around. We doodle an awful lot. We try to remember our Pythagorean theorem, the idea of an hypothesis, and we play around on paper. After playing around, we know that if you give me 2 points, point 1 and point 2, I have my delta x. Notice I use a D for delta x because I can't write a triangle x. The same with delta y. And then we used hypot, which is in the library, that will take the sum of the squares and take the square root of it. And we will have the distance between 2 points. What if I wanted to add 2 points together? I should probably put an ampersand in here. We don't really need it because the point is so small. But if this thing became a Godzilla monster, we'd pass by reference. And you don't even need copy constant here. But so it says take P1, it's X, the second point's X, add them up, create a brand new X. Take the first one's Y, add it to the second one's Y, we have a brand new Y. take those two y's, create a brand new point, and return it to me. This is a very short and sweet function. All of these are very small. And I love small because you can understand them and debug them more easily. What if we had another graphics program, somebody gave me a point and they asked, is it inside this box? Is it inside this rectangle? So we have a bottom point and we have a top point. Great. But we're assuming that those are the 2 points we have, that the rectangle is in standard form. If it is in standard form, then we can use this relationship here about x and y. And you can see if a point is inside the rectangle. If you go back here and you look at it, you can see that there's going to be an x this way. There'll be an x here. So you want to see if its 2 x's are right in the middle there. And then there's going to be a y up here. And there's going to be a y down here. And you check to see if these are also in those regions as well. That's why you see the ampersand sign here, the logical AND operation. Both conditions must be true. And I wrote it on 2 lines like this to make it obvious what I was doing. But what if they gave it to us in non-standard form? Ouch. Maybe they gave me this point and this one. Uh-oh. So what we could do is take, it doesn't matter what the points are, we need to get this thing up here and we need this one down here. So we could take the original x, the biggest x, remember there's going to be an x on the bottom, both sides. Take the biggest x, which obviously should go up here, and then we'll have a y, a small y and a big y. Take the big y and the big x and make a point for this one here. Then take the smallest x and the smallest y and make a point here. And then we could give it any 2 points. We could make it standard, canonical. So here it is. Give me some rectangle. And we'll take a look at the 2 x's and the 2 y's. And we'll pick for the bottom the smallest x and then the smallest y. Then for the top, we'll pick the largest x and the largest y. And then we'll build a brand new rectangle from that top and bottom and return it. And that'll be a canonical or canonized or a standard rectangle. Next, what if are you inside a rectangle? Inside, yeah. Well, we just kind of did that. But here we're showing you how to use it. You give me the middle point, you give me a screen, and now I can ask this question, are you inside the rectangle? And notice how nicely things print out. I can print out points. I can print out rectangles here. I don't know why it does this weird line. The end.